So, welcome to the operating system class. So, we are in a way to take up the case studies regarding the Windows operating system, and we have gone through the architecture of Windows. Then we talked about object management. Now we have yet to start about the thing called as virtual memory layout. Virtual memory layout. So that is the topic what we have to take it up. So in virtual memory layout, so what we are going to emphasize, will be the uh, first thing we will be having physical memory, and physical memory, it is going to be like this, and we call them as page frames. We call them as page frames. Then we are going to have this virtual memory, and virtual memory we are going to call here as some pages, and we will be having PMT, page map table. So we will call this one as page map table, and this page map table, it maps the uh, pages with the page frames. So that is what the original physical memory to virtual memory mapping. So that is regarding the memory management duty. So in Windows operating system, we have files, and collection of the files, we are going to call it as directories. And the directory, it is going to have the way. So we are going to have a way to the files here. So it is implemented in linked list. So this is what we are going to call it as directory, and the directory entry is going to be of a space of 4 kilobyte. It is going to be space of a 4 kilobyte. So 0 to 1023, that is equals to total 1024 kb is going to be the position of the memory content what we are going to take it up. So we can assume here 10424 is the page directory, and the directory, the first value where the directory is going to show that it is going to be of a 4K. And the entities what we are going to call here as page table entries, and they are going to be size of 4 kilobytes. And everything is going to be recorded with a column with a 10-bit integer, and the values you can assume here. So total 0 to 1023, total we are going to assume this one as a total number of entries are 1024. So we will be having a virtual pointer to a byte in the physical memory. So that is what we were mentioning. So there is a linking mechanism which maps the virtual addresses with the physical addresses. So that is where virtual pointer is there. And then we are going to have a state of a pages, whether it is a valid state, whether it is a free state, whether it is modified, nor whether it is bad, nor whether it is empty. So valid, so the page, whether it can be used or not, a page whether it is idle or not, a page whether it is initialized with a value of 0, and whether it is modified or whether it is having bad sectors or not. So that it is going to be taken up. So PDE, we are going to call here as some PDE, you can see the full form, page directory entry here, and PTE we are going to call here as page table entries. So this is what page table entry is, this is what page directory entry is, and it is going to be of 0 to 31. So total it is going to be of 32-bit. Similarly, we are going to have a page table entries, which it is going to be between 0 to 31. Again, it is going to be of some 32-bit. So we have some page addresses, protection bits, and page table. So we and and we are having some extra bits here. So 4 bits they are going to select the page file, and 5 bits they are going to maintain the page protection. So it is 1, 2, 3, 4, 5 bits. So 5 bits it is going to maintain up the page protection, and we are going to have page frame address. So this one it is going to be of 20 bit, and then we are going to have this one as a 4 bit. So 4 bit it is going to select up the pages. So virtual to physical memory translation. So I was telling we will be having a page map table, and it converts the physical addresses. It converts the physical addresses to the virtual addresses. So that is what we were mentioning. So to do this, either to convert a physical address to a virtual address and virtual address to physical address, now it is going to take up the help of physical directory entry, nor it is going to take the help of physical table entry. So that is all regarding this conversions, etc. So we will be having a subsystem. We will be having a subsystem. So we'll be having some Windows 32-bit subsystem that it is going to be in shell, and executive it is going to be in a part of a kernel here. It is going to be part of a kernel here, and what it is going to do, yeah, it is going to make a services to create a thread, delete a thread, and to create a process and to using of the threads, and thereby it is going to have parent child relationship. It is going to select some fork command to create a child process from the parent process. So this is all regarding the Windows architecture primitives. So uh, after this, we will be taking up this a new topic. So that new topic we are going to assume it as some. We'll be assuming here. So we'll be assuming the word. Uh, so this is part 3. So in this part 3, we will be taking up this uh, um, the executive as we were mentioning. So we will be having the Windows 32-bit subsystem. So Windows 32-bit subsystem, it is going to be as a part of shell, and then it is going to be converted to kernel. In kernel, we will be having the operating system, and it is going to be done with this executive word. So what will be the components of an executive? Yes, the components will be the file system. The second thing will be the cache memory management. Third one will be the device drivers, and fourth one will be the network drivers. So what are they here? So you can assume this system here. We can assume the system here. So first one we are going to call here as cache memory management. So cache we will be having as a high speed memory, and that too we are going to call it as an intermediate memory. So why we are going to say that it is a high speed memory? Because it is going to be implemented in the dual double rate RAM, DDR RAM. So DDR RAM, and it works more faster. So dual double rate RAM. So it works of DDR RAM, and it is going to be a level which is next to the register. So we will be having the register, then we will be having the cache memory, then we are going to have the primary memory, then we are going to have the secondary memory. So in this hierarchy, cache memory is going to have the second position. So what does this caching do? It is going to hold all the intermediate contents. So it is having some set of registers which are going to work faster than the physical memory. If physical memory is working for 10 milliseconds, cache memory will work less than 10 milliseconds. So, so in this way, it works more faster to deliver the services to the user. So cache memory, we have different types of cache. that we'll be taking up in this memory management content. So yeah, process management, we talked about it, and then we are going to have a virtual memory manager. So virtual memory manager, we again telling that the physical space, now it is going to be extended with a page map table, and page map table, it is going to take up the virtual memory. It is going to take up the virtual memory. So virtual memory is going to be managed, and virtual memory, it is going to be, excuse me, so virtual memory, it is going to be managed, and it is going to be part of this pages. So that is regarding the virtual memory here, and thereby we are going to have a file system. We will be having this file system content. So file system manager, it is going to maintain up all the different types of files. So there it is going to set up a read operation. It is going to set up a read operation, nor it is going to set up a write operation. So and it is going to allocate files, and it is going to allocate some directory structure. So all that, it is going to have some mounting of disk. So all these events, it is going to be taken up here. And then we are going to have the disk drivers. So disk drivers, they are dealing with the IO drivers. So we will be having some disk driver. So these are all the separate constituents where operating system is going to coordinate up. So this file system, it is going to maintain the addresses, and that too with this word called as LCN. So LCN stands for local cluster number. So it is going to pull up some blocks of disks, and those blocks of disks we are going to call here as a local cluster numbers. So Windows operating system, it is going to set up its DOS prompt. That one we are going to call it as Microsoft Disk Operating System, and it is going to have a compatibility with the Unix operating system. So that is also mentioned, and it is going to have a master file table. So what we are going to call here as a metadata, and metadata we will mention about this as some data about data, data about data, and this metadata, what it is going to maintain, it is going to mention, so where the data it is going to be happen. In the same way, we will be having this master file table, and then we are going to have a page map table. We'll be having a page map table. So it is more or less like a indexed form. We can mention here, it is like a index, so that it is going to be occupied. Now, how is this NTFS, the network file system? So we are going to have this as a network file system. So how is this network file system implemented? It is going to be implemented in a tree structure, and this tree structure, it is going to take up with this B tree structure. So we will be having the indices to the root, and then it is going to work with this binary tree or B plus tree structures. So that is where this diagram is going to take up. So Windows operating system, it is going to use a network file system, and this network file system, it bases a tree structure, and it is going to have roots. It is followed having the intermediate roots, that is the middle nodes, and followed by the leaf nodes, and they are going to be organized in a B plus tree structure, and it is having a metadata, and that metadata we are going to call here as a master file table, and it is going to have the subcomponents in a clusters. Those clusters we are going to call it as a logical cluster node. So we mention this as LCN here. So in DBMS, we have an algorithm called as AIRES. So we say commit, then we are going to call it as rollback. So we have this right to commit followed by rollback to freeze the operations, to unfreeze the operations. So when there is crash recovery, so here we are going to call here as crash recovery when there is a crash in a file. So it has to be recovered at that stage. We are going to work with a stable state. We are going to call it as some stable storage. So table storage, we take this when a crash management has to be taken up, it is going to have a logging of a records, whether to go back to the previous nor whether to go back to the next. So it is going to be taken up with a commands called as commit. So when we are going to call it as a commit, then we say the item is going to be freezed. So we say here undo buffer, and we have a redo operation, undo operation. So those are all we are going to help with a word called as recovery management. So this is all what we call here as some recovery management. So recovery management, it is going to provide a stable storage, and stable storage uses an algorithm called for iris algorithm in DBMS. There it is having to move to the next state, to go to the backward state. So undo state, redo state, and thereby I want to make the transactions a permanent, then I'm going to call it as commit. And to say that to move to the previous state, then we are going to use a rollback. So all of a sudden, if a crash happens in a file system of an operating system, so how it is going to work? So that is where this file system is taking care as part of a data structure here. So this is all we talked about. And files, they are going to have some ownership, and file they are going to have privileges. So that is committing of a privilege, granting of a privilege, and taking back the privilege. So what will be the privilege? It can be a read operation, nor it can be a write operation, or it can be a read or write operation. So this one we are going to call here as an append, nor we are going to call this one state as an edit operation. So those we are going to be part of a file system in Windows operating system. So that is all regarding this topic here regarding the Windows file system. And after this file system, we do have one more topic, and that topic we are emphasizing that topic again. So So the topic is the part 4 here. So sharing my screen, and yeah. So in continuation to this topic, next we do have this fault tolerance. So we will be having single scale, a small scale integration. So that is where SC, SI we will be taking up. And the main agenda for this was how we can protect the data, how we can store the things in large volumes of data. So that is where it is going to be called here as disk management. So how a hard disk is going to be maintained. So how a fault tolerance is going to see that if a disk all of a sudden if it crashes, how can I take back the data? So if there is any fault over a disk, so whether I can recover my data. So that is where the challenge was. So to choose this challenge, so logically we have multiple disks, and they are going to in form of large volumes, and these large volumes, they need to be protected, and for that protected they are going to use a redundant array of independent disks. So redundant array of of independent disks. So we call this one as write technology. We will calling it as, and there are 6 styles here. They will be having 6 styles. So what they are going to see that they are going to give some backup of disks or some storage devices. So it is going to give when there is a fault tolerance, when there is some loss of data, whether the data can be protected. So for that it is taking up this RAID levels. So there are 6 styles. So people, they will be calling it as 0, 1, 2, 3, 4, 5. So these are mentioned with this levels here. So they are mentioned in form of levels here. So here you can see this. The first technique we are going to call it as disk mirroring. The first word we are going to call here as disk mirroring, and level 0 we are going to call it as disk stripping. So first one we call it as a disk stripping, and second one we are going to have disk mirroring. So what are they are going to do is they are going to protect the data, the two in form of some cluster management, etc. So here we can see some two set of drives, So one set of drive, it is going to have some backup here. So we can assume that there is a 2 GB of C drive here, and that 2 GB of C drive, it is going to have a backup on this disk 2, having a disk 2. So that is, it is going to be given in this can color, and this it is going to be in a violet color. So you can see there is some set of volume which it is going to be reciprocated over the second style here. And similarly, we will be having this logical disk drive 0 to 15 implementation, and the same virtual copy, it is going to be in 16 to 31. So in this way, some migration is going to be takes place beyond the disks. So this is the second setup, what we are going to call it as a mirror setup. So I am going to have this C drive 2 GB, and the copy of a 2 GB, it is going to be taken up, right? So we are going to have disk drive of 2 GB, and the same set we are going to call in another set. So we assume that it as a mirror. So the same set of data is going to be again reproduced. So that is what we are going to call it held as a RAID level. So RAID level 1, we are going to call this one as mirroring example, and this one we are going to call it as a RAID level 0. So we will call it as 0 level, and we will be having it as strips. So strips are nothing but some part or chunk of memory. So chunk of memory, it is going to be protected. So some backup is going to be given, not to the entire content, it is going to be given to some partial authentication, etc. So that is all regarding the disk stripping and mirroring. And next one, we are going to have a compression. So compression is nothing but a reduction in size. So how do I compress? So some of the examples you are known with will be WinRAR, nor we will be having this WinZip. So what they are going to do, if I'm going to have some 100 MB of data, then I'm going to make a compress. It will goes to some 75 MB of data, and say 25% is compressed. Then it is going to mention 25% is compressed. So how is this compression it is going to take up? So when disk blocks are contiguous in clusters, so contiguous in sense, we will be saying data is one after the other. So it is one after the another. So data is there, and there is no space, and data will be compact. So there is no empty cells, there is no bad blocks. So everything they are going to be put it up together. So we can say it contains all zeros, and they are not with this actual content. And then it is maintaining some virtual cluster numbers, and then if there is some bad sectors, it is going to fill up just with the zeros. So that is all regarding the compression here. And followed by the protocols, what this Windows 7 it is going to support the Windows 7 protocols, etc. So it is going to be implemented with the server message block. So we will be calling it as SMBs here. So it is going to take up the elements called as session control, file, printer, message. So we will be having this BIOS. So BIOS is nothing but basic input output system. And basic input output system, what it is a mandatory component of any system. So I am shutdowning my system today, and maybe tomorrow or day after tomorrow, what I will do is I will open that system. So today my date is 25th, maybe tomorrow or day after tomorrow. Suppose if it is tomorrow, so obviously it says 26th. I have shut down my system today, but how is this date 25th updated to 26th? So that is a puzzle, right? So the solution was the data, it is going to be in the random access memory, in the read only memory, and this read only memory, it is going to work on a battery here, and this battery, it is going to maintain the date and time. So date and time, even though if the system is shut down, even the mobile phone is shut down, maybe you are going to restart the mobile phone or restart the laptop after a few time, that current time and date only will be updated. The old time and old date will not be updated. So that is keep on updating. So which is the component which is keep on updating the content, means it is going to be updated with this basic input system. And that basic input system, if it is work on autonomous computers, it is in some autonomous network of computers. So it is going to control the date and time for that entire system. So where we are going to call here as a network bias system. So what it is going to do, it is going to give some logical names to the network. So logical names, what will be the logical names? Yeah, these are all the logical names you can see here. So the logical names, it will be a traffic that it can be some WINS, so the domain name service. So all these, they are going to have some logical names here, and then it is going to make a connection, a session between two networks. So and then it is going to have a connection with this network bias and server message blocks. So all this, it is going to taken up with this network protocols. Okay, in networking, you have heard about these words, right? Transmission control protocol by internet protocol, and then point-to-point protocol. We will be calling it as peer-to-peer protocols. Then we are going to have this data link control protocol. So that it is going to be part of this network layer. We will be having this network layer, and we will be having this TCP/IP. So these are going to be implemented in a network layer, not they are going to be implemented in a transport layer. So there we will be having these words. So there we will be saying that it is connectionless, followed by connection oriented. So these are all protected models what we'll be taking up. It is OSA model, this is TCP/IP model. In this way, we are going to say about the network protocols, etc. So that is also taken up as a part of the Windows operating system. So it is going to have some grant access rights within a group. So what will be the access rights? So it is holding some set of privileges. So when it is going to set off privileges, it says some grant connect nor grant resource to user. So to user, to what resource it can give to user, what functionality of an operating system it can allot, so that it is going to taken up with this networking. And then we are going to say a domain emails. So we will be calling it as domain. So for our domain, right, what is our domain? We can say that some the name, that is we are going to call it as username. So we can say svcw.edu.in. So this is our email. Now we are going to say svcw.ecap.in. So this is our email. So these what we are going to call, these we are going to call it as a domain emails. So only these are the legitimate users. These are all going to have the global access to whatever content we are going to put. So I am inviting you with the link. I am inviting you with the Microsoft Teams class code. So you are joining, but other people can't join because they don't have the domain email ID as an invitation. They don't know this classroom as an invitation. So these are some set of grants. These are some set of primitives what it is going to be shared within the network, etc. So those are all going to come into the links where this Windows 7 is going to support. So some major resolutions and some major issues in this TCP/IP, it can be some of the things which it is going to support. That is Windows Internet Name Service, followed by Broadcast Name Service, domain naming services, a host file and a local host, etc., so that it is going to resolve over the IP packets, etc. So that is all regarding the today's class. So after this we have one more content. So that is the fifth case study as a part of Windows system. So so in continuation to the same topic of that, we will be having the Windows 32 utilities. Windows 32 utilities. So utility, yeah, it is going to support OS2, it is going to support some POSIX, and it is going to have some 16-bit application, it is going to have 8-bit application, then it is going to support MS-DOS, and all of them, they are going to be entries to 32-bit 32-bit Windows. So this is where this program is going to take up, and this entire thing, it is going to be in form of a shell, and below that it is going to have some executive, and executive it is going to be awakened with this kernel where the operating system is going to be there, then it is going to be communicated with the hardware. So there are some lot of utilities which are going to be needed with the set of services of the operating system. So we need some priorities. So we need some priority scheduling. We need some scheduling here. So how is this scheduling is going to be done? So that scheduling we will be calling it with some priority levels. So idle process with a priority 4, normal priorities with a level 8, high priority with level 13, real time it is going to be with this level 24. So all this it is going to be a part of this process management. So we have learned about this process management. So in process management, we have taken about priority scheduling algorithms. In priority scheduling algorithms, we mentioned that we have a process name followed by the burst time followed by the priority. So we assign priorities to each and every process it is going to take. So based upon that priority, it is going to compute the waiting time, it is going to compute the turnaround time. So to which job, which priority it has to given, so that it is going to be rendered as a part of this service. So that is regarding the process management here. So then we do have this IO bound job, then we are going to have a CPU bound job as a part of a thread scheduling, etc. So process CPU spending much of a time on IO rather than execution, then we mentioned it as an IO bound job. When CPU it is going to execute much of a time in executing, that is with the CPU usage rather than IO, then we are going to call it as a CPU bound job. So two or more jobs, they are going to be executed simultaneously and parallelly, then we are going to call them as some concurrent execution. So how is this concurrency, how is this synchronization maintained? Yes, they are maintained with semaphores and they are maintained with some mutual exclusion. So all these they are going to be part of this critical section, then they are going to be part of a critical region, nor it is going to be with the monitors. So all this they are going to implement the semaphore concept, all these they are going to implement the mutex concepts, etc. So again, it is going to have some IPC, inter-process communication. So inter-process communication, yes, we were mentioning just now, that is peer-to-peer protocols, peer-to-peer protocol followed by this remote procedure calls. So we are going to work on this client server architecture. So this is client and server architecture. So that is where this RPC is going to stand up. And if it is some point to point, it is from person to person, then it is going to take up with the node to node. It is going to be a peer-to-peer communication. protocols. So Windows, Windows 7 or this 32-bit OS, it is going to support a structure towards network. That too, it can communicate between multiple nodes in a network, and that communication, it can happen between two elements. If it is happening between two elements, they called it as a peer-to-peer communication. And if it is working with a client-server architecture in a two-tier, three-tier, or a multi-tier architecture, then it is going to work up with a commands called as some RPC. So that is where this remote procedure calls is going to hand it up. So that is all regarding today's class. So that is what I can do to. So we can stop here. So ending my class today. So stop recording.